Hi.
Hi.
Welcome back. Last time we were together, we saw how we could use ratios and proportions to figure out side lengths between triangles. Today, we're going to be looking at how to do the same sort of thing, but when we're dealing with parallel lines, what parts of those parallel lines are proportional, and then within a single triangle, those similar parts and pieces. Okay? All right, let's kick it off with, if a line is parallel to one side of a triangle and it intersects the other two sides, it's going to divide those sides into segments of proportional length. What that means is this. I have some sort of triangle sitting here, right? Here's a triangle. And I have some line inside the triangle that's parallel to one of the sides of the triangle. Then the fraction I could write with these two pieces of the side is going to be the same as the fraction I can write with these two pieces of the side. They're in proportion. Okay? Let's practice and see how this works. Join me down at the bottom for number 2. All right, I have a triangle, yes? Yes. I have a line inside of the triangle parallel to one of the sides of the triangle. That means that the fraction I can write with these two things is equal to the fraction I can write with these two things. Notice how I've put both of these parts on the same part of the fraction. They're both in the numerator. And these two parts are both in the denominator. I could have reversed it. But once I've made that choice for one fraction, I have to write it the same way for the other fraction. Okay? This now is just cross multiply and solve. Do y'all want to see me do this now, or are you feeling really comfortable with this one?
I know how to do it.
You know how to do it? Feeling real comfortable? Feeling good? Not sure? Okay. Real quick. So I'm going to take these two and multiply them together. And set that equal to these two things. Multiply together.
It doesn't matter which way you put it. It doesn't matter like if you put 18x equals 180.
Right. I could have written 18x equals 180. That would be fine too. Okay? Can here you see how to solve from here?
How many?
You see what to do from here?
Oh yeah.
Okay. Good. So now that I've got that theorem, I can talk about the converse, which says if a line intersects two sides of a triangle and it cuts it into proportional and corresponding pieces, then that line was parallel to the third side of the triangle. So basically the first one says, hey, you have a line parallel and it intersects, then you get proportional pieces. This one says, hey, you have a line that intersects and it makes proportional pieces, then you have parallel lines. Okay? So this one is the reverse of that. Let's talk about that midsegment. A midsegment of a triangle, which is the line that goes from midpoint to midpoint. Okay? Notice how this piece is congruent to this piece. And this piece is congruent to this piece. That makes this the midsegment. That midsegment is 1/2 of the length of this other side that it's not intersecting. Okay? Let's practice this one. Join me on number 3.
Wait a minute.
Do I have a mid-segment? Here's the line that intersects a triangle. Is this a midpoint? Is this a midpoint? Yes, then that's a mid-segment right here. According to that theorem, that mid-segment is equal to 1/2 of this other third side of the triangle. Okay? And so x is whatever I get when I do 1/2 times 35. Whatever that is. I'll let you guys figure out that number. I have 4 other examples for you. I'd be happy to do no more than 2 of them with you right now. Which one or ones would you like to see? 5? Any others? 6? I heard 4. Which one, 6 or 4? 6. All right, so we'll do 5 and then we'll do 6.
Hey, Miss, would her answer be in decimal or would it be in fractions?
For number 3?
Yes.
That's a wonderful question. I'm happy with whichever one today. Yeah. Thank you. So in case you didn't hear, the question was, for number 3, do you want that answer as a fraction or as a decimal? Today it doesn't matter. All right, number 5. What do I have? Is it a mid-segment? Is this piece the same size as this piece?
Yes.
It's not marked, so I don't know. So, not a mid-segment.
So that full line is 32.
Mm-hmm.
And it's 1/3.
Yeah, it's 1/3, not 1/2. Yeah, so they're not congruent. So this isn't a mid-segment. But I do have a triangle where this segment is parallel to this line. Which means the fraction I can write with these two has to be equal to the fraction that I can write with those two. So my fraction can be, I just need to figure out what this piece is.
Wait, oh yeah, 22?
Yeah, 22. Would anyone like to see this one get solved?
Yes.
Yes? Okay. Because I want to write a little big and I'm a little out of space here, I'm going to do it on another sheet of paper. All right, so there is the problem we're solving. Okay, this is a 2. All right, cross multiply solve says I'm going to take this thing and I'm going to multiply it to this thing. So I have 22x. That equals this thing times this thing, which is 11 times x plus 12. I'm going to do some distribution right here. And now I'm going to subtract 11x from both sides. Divide both sides through by 11, and I get that x equals 12. Questions? Feels okay? All right. I was also asked for number 6. So I'm going to switch back to our paper here so that we can look at number 6. There's number 6. It's the same setup as we just had, isn't it? So then, which fraction could I write? I could write 10 over 30, which reduces to 1/3, equals x over x plus 10. Very good. And so, just so that way you have it, this was the proportion that y'all said we could write. Good. And the cross multiply solve on that is exactly like the one that we just finished doing. Do y'all want me to walk through that one too, or are you feeling comfortable with it now? Comfortable? All right, when you're ready, join me on the next page. We're on the next page. All right. So now that we handled the parallel lines in triangles, we're going to talk about what happens when these parallel lines are running into transversals. Okay? So if 3 or more parallel lines intersect 2 different transversals, then they're going to cut the transversals proportionally. What? I've got 3 parallel lines. 1, 2, 3. I have 2 transversals. 1, 2. Cutting them proportionally means that the fraction I can write with those 2 pieces equals the fraction I can write with those 2 pieces. That's all it means. Okay? Join me on number 7. I want you to write this as small as you can on your paper. I'm going to transfer it to a big sheet of paper so that you can see it in a minute, okay? Because there's a lot to write. All right, do I have 3 parallel lines? Yes. 1, 2, 3. Do I have 2 transversals? Yes. 1, 2. That means that the fraction I can write with these things equals the fraction I can write with these things. And that is the equation I have to solve. There it is. There's the equation. Cross multiply. This thing times this thing. That equals this thing times this thing. Is it too shady? Come on, Elmo. It's not, the name of the thing is Elmo. 36, wait, okay, I'm going to do 3x times x plus 12 because I can't think too many multiplications at once. Okay, so then this is 60x, and then here I'm going to do 3x times x. Now, in reading your 7-1 homework assignment where you had to do something like this, I saw quite a number of people looking like they're not quite sure how to handle x times x. A lot of you are turning it into x plus x. Yes, and so x times x is x squared. So 3x times x is 3x squared. Good. Don't worry, as I was looking at your 7-1, if it looked like there was some confusion on that, I as long as your setup was right, I gave it to you. Okay? I was checking more setup than anything else. Okay? But now, from now on out, we're going to be doing it better. Yes? Okay. Now I have to solve this thing. That x squared is frightening. First thing I'm going to do is I'm going to get all the x's together on one side of the equation. So I'm going to get rid of it on this side, and I'm going to move it over to here. Okay? That's going to get rid of it here on the left. Now that doesn't mean I don't have anything there. It just means now I have a 0. Just 0. Well, I get technically 0x, but 0 times whatever is 0. So I don't need to write the x. I'm just going to write 0. Okay, good. So my 3x squared stays the same. And this is negative 24x.
And Miss, why'd you subtract the 60 instead of like 36?
Because I wanted all the x's to be on the same side of the equation. And if I had subtracted 36, I would have had something x on the left and then 3x squared on the right. And I wanted all the x's to be together. It makes it easier for me to tell who I shouldn't date if all the x's are in the same spot. All right. Now that I've got this thing, one of the methods I could use to solve this is to factor it. And I'm going to show you how to factor things like this. So I'm going to look at this piece, and I'm going to go, what are all the things I need to multiply together to give me 3x squared? Well, 3 times x squared. But x squared is really x times x. So these factors are 3 times x times x. Those are the factors of that. Yes? Yes. All right, next things next is I'm going to find all the factors of this thing. Negative 24x. I'm going to think of that negative as negative 1. So now I have 24 to deal with. I could just write 21, but I want things that match with the factors of the other number that I just worked with. So 3. Does 24 have 3, Ethan, as a factor?
Yes.
Okay, so 3 times what is 24?
8.
Good. So I'm going to write 3 times 8. And so these three numbers, negative 1 times 3 times 8, that's negative 24. Times x, because I still have that x sitting there. I've listed all the factors. You okay with that? Is that okay? All right. The next thing to do is to circle the ones that they have in common. They have 3's in common. They have x's in common. So I'm going to write that thing that they have in common. And then in parentheses, I'm going to write what's left over. X. And those need to multiply together. Negative 1 times 8. Negative 8. And I have factored this thing. Very few algebra teachers will write this out for you every single time because they're doing it in their heads and they're assuming that you can see the factors the way they can. Okay? I know not everyone can, so I'm going to write them out for you until all of you go, nah, we're good. Okay? Feels okay? Okay. So now I have that thing. 0 equals stuff being multiplied together. But I have a trick. Anytime I have stuff multiplied together and equals 0, this could be 0, or this could be 0. And now I have two very simple equations that I can solve for. I have this one on the left, and I have this one on the right. X equals what in this equation? Equals 0, because 3 times 0 is 0. What does x equal in the right-hand equation? 8, because 8 minus 8 is 0. And this, along with that, are both the possible correct answers for this equation. They're both solutions. So if a builder had come up to me and handed me this problem and said, I need to know how much wood I need to buy to make this thing, I would go, well, you either need to buy X equals 0 feet of stuff or X equals 8 feet of stuff. And he may look at me like I'm weird because 0 feet of stuff, like I'm telling him don't go buy anything, which is weird. But they're possible solutions, okay? I just don't know if they make sense or not. We okay with that? Okay. Congruent parts of parallel lines. If 3 or more parallel lines cut off congruent segments on one transversal, then they're going to cut off congruent segments on every transversal. Okay, so if they do it for one, they do it for all. Join me on number 8. Okay, here's number 8. Do I have 3 or more parallel lines? Yes. Are they cutting a single transversal into congruent pieces? Yes, then that means that they cut the other transversal into congruent pieces. I can write an equation with any 2 of these that I like and get to the correct answer. Which 2 do you want to use for the equation? The first one and the third one? Okay, so read for me the equation.
12x by 12 times x plus 2.
Equals. 12 equals.
Oh, so equals x plus 2.
Yeah. Because this piece is equal to this piece. All right, I'm going to solve that for x. I'm done. Good job picking a simple one. You could have picked any 2 that you liked. Okay. If you're not sure which 2 to pick, it doesn't matter. Just pick 2. 2 that look pretty. I think you picked those because they seemed the simplest, yes? Yeah. All right. I've got 2 others here for you. I'd love for you to try on your own. And tomorrow, when we come back, we'll go over them really quickly. Okay? Before we finish out our notes. Any other questions before we call it a day? That's it for now. Thank you very much.